Okay, good day everyone. So, for today's lesson, we're about to tackle quadratic functions, and we're gonna go on part of graphing and analyzing the effects in the changes on some parts of the quadratic function. And that's our topic that includes Math 9 for the first reading period. So, let's go graph y is equal to x squared plus 3x minus 4, and we will identify the following: the domain, the range, the opening of the parabola, the vertex, the axis of symmetry, the x, and the y-intercepts. So before we proceed, let's define these following parts. We have the domain. So these are the set of x values in the graph. So it means that these are the possible values of x that can be included in the graph. These are the ranges of the x values that can be used in the graph. In the range, so we have the set of all y values in the graph. So these are all the possible y values that we could use in the graph. So the opening of the parabola, this will be the orientation of the graph. So in our lesson, there are only two orientations that we're about to discuss. So for vertex, this will be the minimum and or the maximum point of the graph, depending on the orientation of the graph. So the axis of symmetry, this is already the axis that divides the graph into two equal parts. So we have here the x-intercept. So this is the point where the graph intersects with x-axis. We have already known that in your grade 8 class. Y-intercept, this is the point where the graph intersects with y-axis. So we have already defined this one. So if you want to go back on this definition, you may take a screenshot on your phone if you're using cell phones or mobile phones, or you might be write this down on your notebook so that you could browse back again in this definition. So let's proceed. So to graph this one, we need to get the important parts of the graph. So they are the x-intercepts, the y-intercept, and the vertex. So as you can see, we have here the plural x-intercepts. So at most, a quadratic function has already two intercepts. So why? Let's find out. Okay. So we have here the function y is equal to x squared plus 3x minus 4. So for the x-intercept, we have to consider that the y is equal to 0, since this point is already lying on the x-axis. So there's the value of y is already 0 when it is in the x-axis. So let's substitute y is equal to 0. So you have here 0 is equal to x squared plus 3x minus 4. So as you are about to review, this is already set in the standard form of the quadratic equation, where in fact the other side is 0. So we're going to find the roots of this function, so we could find out for the value of x that will be serving as the x-intercept. So to solve this one, I will going to use factoring. So the factor for x squared plus 3x minus 4 is x plus 4 and x minus 1, and it is equated to 0. Next, let's proceed to the zero property of equality. So both will be equated to 0. X plus 4 is equal to 0. X minus 1 is equal to 0. So next, let's simplify. We have here the value of x is negative 4 and x is negative 1. So there are the x-intercepts of the function. For the y-intercept, so since it is already lying on the y-axis, so the value of x will be 0. So let's substitute 0 in the function. So y is equal to 0 squared plus 3 times 0 minus 4. So 0 squared is 0, 3 times 0 is 0, and then it will be subtracted by negative 4. So 0 plus 0 minus 4 will give you negative 4. So the y-intercept is already y is equal to negative 4. Okay, we have already this x-intercepts and y-intercept. So let's find out for the vertex. Okay, so to find for the vertex, what we need to do is to make an ordered pair in the form hk. So in the past lesson, we have already discussed the formula for h and k. So that will be negative b over 2a for h, and that will be 4ac minus b squared all over 4a for k. So we are about to substitute for the values of a, b, and c to fulfill the ordered pairs. So in this case, we have here the value of a is 1, b is positive 3, and c is negative 4. Let's substitute that. So we have here negative of 3 all over 2 times 1, and then the y value will be 4 times 1 times negative 4 minus 3 squared all over 4 times 1. Let's simplify. So this will be 2, and then this will be 4 times 1 times negative 4 is negative 16, negative 3 squared is negative 9 all over 4, and then we have the final answer of negative 3 over 2, negative 16 minus 9 is negative 25 over 4. So this is already our final answer. But if you like to be sure, and if you're going to plot this point, you may change this improper fraction into the mixed fraction form. So we have here negative 1 and 1/2, and the y value is negative 6 and 1/4. So that is the ordered pair hk. So let's plot our points in the Cartesian plane, which is right here. So we have to understand the opening of the graph. So if a is greater than 0, then the graph goes upward. Conversely, if a is less than 0, then the graph goes downward. So in this case, in this function, a is 1 and a is positive. So therefore, the opening of the graph is upward. So here is the graph of the function. So you could see here the x-intercepts. We have here negative 4, 0 and 1, 0. We have here the y-intercept here. We have here negative 4, 0, and here is the vertex, which is the minimum point of the graph. We have here negative 3 over 2 and negative 25 over 4. Okay. So the axis of symmetry here is evaluated as the value of x is equal to h. So the h here is negative 3 over 2. So as you can see here, we have here this red line here. We have here the red line here, and it divides equally the graph into two parts, and it intersects passing through the vertex. Okay. So the domain of this function is, if you can see, it is, as I have already said a while ago, the domain is already the set of x values in the function. So as you can see, if you're about to look on here, the graph, if you're about to expand it, the graph, it will be continue to widen and widen. Will continue to widen and widen. Therefore, the domain is the set of all real numbers. So any real number can be the value of x in this function. So for the range, we're going to see the range has already limited values. If you could see, the graph here goes down and then goes back again. So there are already limitations on this range. So if we're going to go in this area, this doesn't go here. Therefore, this doesn't include in the y values. So we're going to see that the value of range is the value of y, such as the y is greater than or equal to the value of k, and the k here is negative 25 over 4. So we could say that the range is the value of y such that y is greater than or equal to negative 25 over 4. So it should be greater than that. We're going to see. Okay, so let's have another example. Let's graph y is equal to negative 3, the quantity of x plus 5 squared minus 9, and identify the following: domain, the range, the opening of the parabola, the vertex, the axis of symmetry, x-intercept, and the y-intercept. Okay, so to graph this one, again, we will be needing the x-intercepts, y-intercept, and the vertex. So here's the function. So the function here is in the vertex form, so this will be easy. We can now get the coordinates of the vertex by just looking on the function, and in this case we could see that 5 and negative 9 are right here. So we could say that the value of h and k, the vertex, will be negative 5 and negative 9. Why negative 5 and we have here 5 here? If we're going to look, the vertex form is already in a times x minus h plus k. So therefore, if this will be negative, and therefore, in order for this to be positive, there will be another negative for this one. Remind you again, the formula is negative and the value is negative, so we've come up here with a positive. So we could conclude that negative will be the value for this one, and then we're just going to copy the value for this one. So we have here negative 5 and negative 9. Okay, so for the x-intercept, we have to go to y equals 0. So 0 is equal to negative 3 times x plus 5 squared minus 9. And then let's expand this one. We have here 0 is equal to negative 3 times x squared plus 10x plus 25 minus 9. Then we're going to multiply this one. We're going to have negative 3 times x squared is negative 3x squared, negative 3 times positive 10x, negative 30x, negative 3 times positive 25 is equal to negative 75, then minus 9. And then let's simplify. So 0 equals negative 3x squared minus 30x minus 84. So let's extract the negative. We have here the quantity of negative of 3x squared plus 30x plus 84. So as I am about to plan to probably solve for the roots of this equation, but if you're going to find it out, you can factor it. Probably you could find another number, and if you're going to use the quadratic formula, you're going to come up with no real roots. So if the x-intercept, if the roots of the function here doesn't have real roots, therefore there will be no x-intercepts for this function. Okay, you have to be reminded of that. If there are no real roots in finding the x-intercept, then there will be no x-intercepts. Okay, so for the y-intercept, so let's have this one. Y is equal to negative 3 times 0 plus 5 squared minus 9. Okay, so we have here 0 plus 5 is 5, then it is squared, then we have minus 9, then we have a negative 3 times 25, which is the square of 5, minus 9. Negative 3 times 25 is negative 75 minus 9, and negative 75 minus 9 will give you negative 84. Therefore, the y-intercept is negative 84. So we have here this should be right here. So let's plot our points. So we have here the opening of the graph. So here's the function. A is negative 3 right here. So in this case, you could see the function right here. We have here, since A is negative, so you're going to see the direction is downward. And as you notice, this graph doesn't go here in the x-axis, showing that our statement right there is correct. There will be no x-intercepts in the function, and then it intersects right here. It's roughly negative 84. So here's our function. So the axis of symmetry is, again, will be the value of h. So it is x is equal to negative 5. So the domain is the set of all real numbers, since all values of x can be included, as we are about to expand and go through the function. And the range, as you can see on this part, the y part doesn't go here. So the value of y will be, must be less than or equal to k. Sorry for the error. So therefore the value of y is y, such as y is less than or equal to negative 9, which is somewhat right here. Okay, so here is the axis of symmetry. Next, let's consider the following quadratic functions for this one. Okay, so we have here the sets of functions. We have here, you're going to see that we have here the same thing. We have here y is equal to all x squareds but different coefficients. So you could have 4, 3, 2, and we have here 1 here, 1/2, 1/4, and 1/8. So you're about to look on this function. The y is equal to 4x squared. You could see this graph right here. It's quite steep, and as you go through, we have here y is equal to 3x squared. It goes less steep, 1 to x squared, then x squared, and then as we go on, we have here 1/2, 1/4, and then 1/8. It goes less steep. So you could see, as the number increases in the coefficient of x squared, it goes steeper in this graph, and as it goes smaller, you could see that it becomes less steep. So in other words, as the value of a increases, which is right here, the graph becomes narrower. So it becomes narrow. So we're about to increase this one. Say for example, we're gonna have 8x squared. It will be narrower than we thought. And as the value of a decreases, the graph becomes wider. So as we're about to get smaller and smaller in the graph, smaller and smaller in a, the graph becomes wider and wider. Okay, so that's thing that we noticed. Okay, another set of function. So we have here x squared. So we have here sets of x squareds right here, but you could see we have here accompanied here with another term. So we have here positive 4, positive 2. We have here nothing here, negative 1, and negative 3. So here, if we are about to look here, I think they are just the same. It's just that the vertices of the graph are different. We're going to see, as we have here 4, 2, 2, nothing, so it goes with 0. We have here negative 1, then negative 3, negative 3. So as a conclusion for this one, the quadratic functions here are in the format of y is equal to ax squared plus k. As the value of k increases, the vertex of the function goes up. So it goes up as we're going to use an increasing value of k. And as the value of k decreases, the vertex of the function goes down. So as we're about to approach a negative value, it goes goes down, down, and down. So here's the consideration that we're about to do. Okay. The next function is quite different from the previous set. So the function right here is already included in the parentheses, and it is already squared. It's not just x squared, but then it is x minus 2 squared, x minus 1 squared, and here's the simple x squared. Then we have here x plus 1 squared, and then we have here x plus 2 squared. Okay, so let's look here. We have here negative 2, and then let's go here. The vertex is on positive 2. Negative 1, here's the graph. The vertex goes with positive 1. And then x squared here. So 0 is the vertex. Positive 1. So here's positive 1. The vertex is negative 1. And then positive 2. We have here negative 2 as our vertex. So, as you could see, there is already a lateral movement of the vertices in the graph, unlike the first set of values right there. So you could see that there is already a difference. The quadratic functions here are in the format of y is equal to a multiplied by x minus h squared. So as the value of h increases, the vertex of the function goes right, and as the value of k decreases, the vertex of the function goes to the left. Wait. I think this might be confusing. Maybe sir, you're wrong. No, I'm just telling the right thing. If we're going to see, the formula here is negative h. So therefore, if we're going to look here, if this is negative 2 and the formula is negative, therefore I'm pertaining to a positive value of h, since the formula is already negative. So therefore, the value here of h is already a positive thing. So therefore, as the value of h increases, the vertex of the function goes to the right. So as you can see, the vertex of the function goes to the right, and that's consistent to what is the graph here and what is what I am saying right away. So we have here x minus 2, 2 is the graph. So x minus 1, 1 is the vertex. So conversely, we have here positive 1. So in other words, so the formula is negative. Therefore, if this positive, it becomes the value of h is negative right there, because negative times negative is positive. So therefore, in order for this to be positive, the value of h must be negative. So as the value of as the value of h decreases, the vertex of the function goes to the left. So this is negative 1 here, negative 2, negative 2. So I'm getting things clear for this one. This will be quite challenging while you're looking for the vertex of the function as we go on, but please consider this one. Okay, so let's combine and practice this one. So graph the following functions in the Cartesian plane, identifying the vertex and the opening of the graph. So here y is equal to 4 times x plus 5 squared minus 7. So the vertex right here is we have here negative 5 since it is positive, and then negative 7, and then the value of a is 4, and the opening is upward since the value of a is positive. So the graph goes like this. So you can see the vertex is negative 5, negative 7 right here, and then we have here the value of a is 4, so the graph goes upward. Let's have the second one. So we are now y is equal to negative 3 times x minus 6 squared minus 10. Again, the vertex will be 6 since this is already a negative part of the formula. Then we have here negative 10, and a is negative 3, so the opening is downward since a is negative. So here is the function. As you can see, the vertex is negative 6, then we have here negative 10, then and it goes downward. So here is the function. So okay, so let's proceed with our third example. We have here y is equal to 3 times x minus 4 squared plus 8. So the vertex here is already 4 and positive 8. And then we have here the value of a is 3 and a is positive, then therefore the opening is upward. So here's the graph of the function. So you have here 4, 8 as our vertex, and then we have here the opening of the graph as upward. So this concludes everything for this day. So if you like this video, if you enjoy this, so you could have like on my video and share this with your friend who is already in your grade level, with the same grade level as yours, and then don't forget to subscribe on this channel. Thanks so much for watching.